Good afternoon, everyone. Thanks for joining our weekly webinar. Today's topic is basics of die casting, and we have a very experienced person with us for the topic. I would like to welcome Mr. Raman sir now to basically introduce the gathering and give a speech. Yeah.
Okay, thank you, Siddharth. My voice is clear?
Yes, sir. You are audible.
Yes, sir.
Thank you. Welcome, Saminathan sir, on behalf of Indian Institute of Foundrymen Chennai chapter. It's my immense pleasure to welcome you all this August gathering for the wonderful presentation to be made by Mr. Saminathan. IIF Chennai chapter week on week is providing webinar training to all the beneficiaries, and 1 week in a month we are conducting management program with MMA. So that's the calendar we have been following, and the rest of the year also we formed the calendar like that. So in that connection, this week we organized with respect to die casting, that is the basics of die casting, where high pressure die casting is predominantly involved. So that particular topic is going to be detailed by Mr. Saminathan, who is a die casting consultant, trainer, and technology facilitator in Aluminium and Zinc with regard to high pressure die casting. So in earlier days, we used to do the aluminum castings through gravity die or sand casting or tilt casting, whatever may be the form. So now everything is changed to high pressure die casting, and the precision level of castings are expected much. In the olden days, we used to produce a gearbox in gravity die casting, where we came across the issue of a bend and the dimensional inaccuracy and predominantly shrinkage defect in the casting. So all those issues, all those irritants have been completely eliminated by HPDC process. So now lakhs and lakhs of castings are produced through HPDC, irrespective of the shape, weight, or any criticality in the profile. So in that context, now I request Mr. Saminathan to give us a fantastic presentation so that all of us can enrich our knowledge and enhance our level of understanding in technology. And I request all the participants to switch off the mic so that the clear communication will be there, and the relevant questions can be raised at the end of the program so that Mr. Saminathan will be in a position to give the direct clarification on that. So with that note, I request Siddharth to introduce Saminathan to the forum and take thereon. Thank you. Over to Siddharth.
Thank you, sir. Thank you, Raman sir. As Raman sir indicated, I'm requesting all of you again to please mute your mics, and whatever question you have in the presentation, you can please send the message. I will be closely following the messages in the Teams, and if needed, we can reach out to Swaminathan sir then and there and ask the questions. Other than that, please make sure your mics are unmuted. Now, amongst us, Mr. Swaminathan, we can probably say we are blessed to have you here, because the amount of experience and knowledge he has in this field is uncomparable. To give a brief about Mr. R. Swaminathan, he is basically a die casting consultant, trainer, and technology facilitator in aluminum and zinc process. He is a seasoned professional who has worked in various areas like production, process, engineering, tool maintenance, NPD, maintenance, and operation. He has also completed his diploma in mechanical engineering in the year 1991 from SS Polytechnic, Sirgali, and completed his MBA operations from Jaro Education and Ulyanovsk State University, Russia, in the year 2015 by distant education. So you can understand that he's been a continuous learner for all these years, and he basically started his career as a production engineer and was promoted to senior level due to his sincere and hardworking nature. He is a well experienced in die casting field for more than 27 years and has worked with well-established die casting industries like LTEX Rudy Limited, Coimbatore, Pioneer Die Casting Industries, Malaysia, G-Plast Limited, Coimbatore, Chamundi Die Cast, Tumkur, CRP Private Limited, Chennai, Alpha Craft, Coimbatore, Sandhar Technologies Limited, Bawal, and with Endurance Technologies Limited, Chennai. That's pretty much all the pioneer companies in the field of non-ferrous, and he is well experienced in practical as well as in theoretical and acquired knowledge from FRECH and Bühler, Germany in tool design and process design in aluminium and zinc process in both cold and hot chamber. He has constructed many HPDC tools for cold chamber and hot chamber processes for thin wall, medium and thick wall castings, and which has given really good output, yield and less rejections with meeting all customer requirements. He has handled cold chamber machines capacity up to 1600 tons, and brands like Bühler, French, UBE, Toshiba, Toyo, Zitai, LK and HMT, and with other local machines as well. He has handled PDC shops with 20 machines and 8,000 TPA of aluminium with over 120 turnover per year. He has supported many OEMs for their new casting development from scratch, such as Husco Hydraulics, HP, TVS, Bosch, and worked with many overseas customers in Europe, USA, Japan, etc. in the field of automotive, electrical and electronics, structural, textile, tractor, agricultural, and aerospace industries. R. Swaminathan has supported die casting manufacturers to improve their profitability by productivity improvement, rejection control, cycle time reduction, energy saving, and developing skilled PDC personnel. Currently, he is supporting die casting manufacturers, machines and equipment manufacturers, and casting end users in consulting, business development, HPDC related services, and supporting die casting employees for training and skills. He is also a member of Alucas, GEC Tech Forum, IIF, and NATCA. Sir, we are very, very honored and happy to have you amongst us. The webinar is open for you. You can please take the stage.
Good afternoon to everyone. Thank you for the opportunity given to introduce myself for IIF and give me the opportunity to give you the presentation about the high pressure die casting. As you said, now high pressure die casting is moving everywhere, and today we will discuss about basics of high pressure die casting. So why I have selected this topic? The basics are very, very important for high pressure die casting to get the good castings in terms of quality, in terms of delivery, in terms of cost. And already Mr. Siddharth explained about my career experience, etc. So I will skip this slide. And our services from Die Casting Engineering Solutions is consulting, training, skill development, and high pressure die casting and zinc process, cold chamber and hot chamber process. Our objective in training is providing training to improve and upgrade the knowledge and the skill level of production team to cater the challenges of new requirements. So objective of this webinar is basically to make awareness of basic requirements in die casting production, and also we will discuss a brief discussion about the customer demand nowadays. So what is basics? The things that you need most, because people in the shop floor, wherever working in the tool maintenance or machine maintenance, they always skip the basic things. So I insist to focus on the basics. So topics to discuss here is a 4M condition in shop floor, general points in the production, die casting process and process parameters, molten metal requirements, die casting process condition requirements in the shop floor, melting and holding furnace, important points, die casting tool maintenance, die casting machine daily maintenance, the production management, customer demand, and about training necessity of employees. This is the basic high pressure die casting of cold chamber. There is a fixed die and moving die in the mounted over the fixed platen and moving platen. The metal is poured into the short sleeve, and the injection is performed by the plunger. This is the basic of high pressure die casting. See, cold chamber high pressure die casting, liquid metal, that is aluminium, like ADC 12, from holding furnace with required temperature nearly around, this is the around 680 degrees Celsius, is poured into the short sleeve and injected by the moving plunger with a high velocity and pressure, and keep the die for a few seconds, few milliseconds to cool down or solidify. And the casting die is opened and the casting is ejected out from the tool by ejection system after the die open. This is the basic process. See, in the die casting, the 4M conditions. In this section, we will discuss about 4M conditions for a good die casting process and achieve the production targets. Already everyone knows about the man, machine, material, method of the process, and also I have added two more things: equipments and environment. Here, the 4M in high pressure die casting, man we called as knowledge and the skill level of employees who are all involved in the production of casting or components, importantly workmen in the shop floor. So I am insisting here the skill level and the knowledge level should be up to the mark. And the machine, the usable condition, not like a machine, the machine should be in the usable condition of the PDC machine, and the usable condition of the die, tool, furnace, and the major components, etc. all should be in the usable condition. And the material means the quality of liquid aluminium or the zinc at the pouring point or the injection, not only at the holding furnace. It should be at the pouring point. And the method, the process or the process parameters, it should be the proved or validated method. The method should be validated previously. During the production, we have to use these validated method. And the other component, other important conditions, the equipments, apart from the 4M, this both equipments and the environment. The equipments like the peripheral equipment, the trim press, trolley, the degasser unit, the crane, other required equipments, etc. should be in the usable condition. Environment suitable for carrying out production. The environment should be clean, the easy access without any hazards, optimized, the layout should be optimized, and the practice have to be 5S. See here, the environment, sometimes when we go nearby the injection area of the machine, always we can see some kind of oil or water spillages. The operator or inspector cannot access to that area. That's why I'm insisting here that these are all the basic things that to be taken care by the shop floor people every time. And the general points about the man. The shop floor employees like engineers, frontline supervisors, operators, or executives of management activities. And so that their knowledge level and the skill level are very important to achieve targets, production target, quality target, or delivery target. The costly mistakes can be avoided in certain extent by providing training in their working area. If the operators are trained properly, if their knowledge levels are up to the mark, so we can reduce the costly mistakes. And the general points about is continuing. Focus is needed in any work to achieve objectives and target. Any assumption should be avoided. Assumption should not be there. For example, when you set any process parameter, for example, material temperature or injection parameters, we should not have any assumptions whether it should be validated properly as per the calculations. So the calculation will help us 80%, 20% have to be validated properly. And no compromise any process settings. So for example, when we see any leakages in the machine or any water leakages or any air leakages should be arrested. Otherwise, we will not get the consistency in the process. And the preparation is more important for early execution of the production. The preparation means before start of production, especially in the high pressure die casting, everything should be properly kept in nearby the machine. For example, after start of the first shot, the operator is always wandering or searching for ladle coating, ladle cup, etc. This should be avoided. Otherwise, what will happen by the time the die will cool down? So the systematic approach in any process will give you desired result. Systematic approach. Any process should be followed as per the written down statements. And attitude, commitment, teamwork, and good work culture are also very important for achieving the goals. The safety of workman, the safety of machine, safety of tool and equipments give importance. So I insist to give more importance and practice norms without fail. For example, the operators are entering into the shop floor without wearing the safety shoes and goggles. So the accident not happening every day, sometime for a year or for a while. So what will happen? It will give a major impact on the production and delivery and etc. And don't bypass any safety interlocks in safety door, auto ladle, and a safety hook or any other safety device. For example, the safety door, you want to increase the production, they interlock the safety door. Sometimes the operator fall down into the machine and the fatal incident happening sometime. So this should be avoided. And the oil, water spillages to be eliminated. Keep fire extinguisher in ready condition. So now we will talk about the material. The quality and the quantity of liquid metal pouring at the short sleeve to make it short. It should be the quality mean right temperature and the quantity mean right quantity of the material. What will happen? The quality, for example, the aluminum oxide may enter into the aluminum. It will create the flow problems. So the quality should be kept properly, and the quantity also. If the quantity is lesser, the biscuit thickness will reduce. So the final pressure won't be there, and we will have a solidification shrinkage. That's why both are very important. And always conforming to spec and composition. So every time, no, I think not necessarily to check every pouring, and in between have to conform to the specification. The cleanliness of the, without any oxide and intrusions on gas, it will affect the flow and leads to defective castings. Maintain homogeneity of liquid metal at the holding furnace. So try to melt in the separate melting furnace to maintain the homogeneity. If you melt the runner and riser inside the same furnace, what will happen? The quality, the temperature, and everything will deteriorate. That's why I insist to melt the aluminum, the separate furnace apart from the holding furnace. So the mixing ratio, normally we use 60-40, sometimes 50-50, because to compensate the magnesium loss. And also to validate as per your requirement. Sometimes 70-30 also possible. So this is my guideline. And the ladle cup design. See, this also to eliminate the oxide metal, enter into the molten metal, to bail out metal from the certain level below the surface of the melt with the uniform composition and without any oxides. Normally we use the ladle cups in open type. Some designs are available in the market. At the top side is closed and a small lid is opened, a small slit at the little 10 to 15 mm below the top surface of the ladle. So that what will happen, the good liquid metal go into the ladle. So good metal poured into the short sleeve, and we will get the good components. And don't stir the surface of the melt too much, as it will create oxides. So sometimes the operator want to clean the ladle cup, always the educator too much at the top surface, and it will create the oxides. This should be eliminated. And avoid melting of aluminum chips with ingot and a runner and cast. It will create more dross. So can I take a break? I want to have water.
Yes, sir. Sure. No problem.
If anyone have questions, please note down, and at the end of the session, we will clarify. And the chemo test as per the customer requirements. This is the easy method of qualifying the molten metal. So this is like one type of chemo test apparatus. You can see there is a opening at the top. So we can pour the material inside the ladle. And this is the sample. The A is the full sample. The left side B is the cut section without any porosity in the cut section. And the right side C, there is the inclusions. And the K-mole value, the cleanliness of the melt is expressed through K-mole value. This value is based on the visual inspection of the surface of the test pieces and count of the number of inclusions on the surface for the evaluation of the cleanliness of the melt. So K-mole value is equal to S by N. K is the number of inclusions found in one pieces of the sample within the fracture surface. And S, total number of inclusions found in the N pieces of the small probe. And N, number of examined samples. So by using this exercise, so we can find out the number, how many number of pieces having the porosity or inclusions. Every casting plant need to establish its own scale or range for each product based on K-mole value. So the lower K-mole value means cleaner the melt. If you do not have, if you break 5 pieces, 5 into 4, 20 numbers maybe. So if you find more number of pores, so the melt have a problem. So we have to do some cleaning process. This is the guideline. This is a simple process. You can adapt in the die casting shop floor. The material, the metal temperature, normally I insist here 650 to 700 degree as per the casting quality requirement. For a thin wall component below 3 mm, it is around 680 to 700. The medium wall thickness may be 3 to 9 mm. It may be around 670 to 690 degrees Celsius. For a thicker wall castings, we can use 650, nearby 650, below 670. This is just a guidelines for you. Again, this all need to be validated properly, recorded properly, and should be used in the production as per the validation report. So the melting and holding furnace, we will discuss about the melting and holding furnace. What are the things don't and don'ts? The don't and don'ts of both the furnace should be followed for the maximum output and performance of the furnaces. Normally, we will get the information from the furnace supplier, the crucible supplier, the holding suppliers. It should be kept properly and write down and converted into the SOP and hang it in the machine, and training should be given to the operators. What are all the don'ts? For example, when the operator is cleaning the holding furnace, normally they will harshly hit the crucible and hit the furnace wall. It will damage. That's why it should be properly trained. And the preheating and adjustment of flame or the adjustment of the coil in the both furnace is to get uniform heating, the proper adjustment. And do not hit the wall, as I said previously, on the furnace and crucible. And don't charge the cold material. Sometimes the operator want to supply the material to the line, they immediately charge the cold material. What will happen? It will burst, or sometimes it will take more heat. It should be preheated previously. And the oil scrape and contaminated metal should not be charged in the melting furnace or holding furnace. It should be treated separately. And use correct proportion of cleaning agent. It should not be approximate. When you have a 250 kg of holding furnace, it should be used 250 grams or as per the supplier recommendation, and also have to do validation properly. These are all the basic things. That's why I again insist basic things. Try to avoid a chlorine tablet for degassing. Sometimes this won't give much effect on degassing because it creates big bubbles. It won't take clean the molten aluminium properly, and also it creates aluminium chloride, and it will eliminate all the chlorine. Magnesium, it become a magnesium chloride, so it will take away some percentage of magnesium from the molten metal. So N2 gas purging is preferable, more effective. So, and avoid overheating of alloy. It will create more dross and loss of material. This is also happening in the shop floor sometime. So we have to insist the operator overheating, or else make it cut off in the furnace. The daily cleaning of melting furnace and crucible with the right tool are most important for good performance. Daily cleaning should be happened in the melting furnace. Otherwise, what will happen? The aluminum oxide will deposit in the wall and become a corundum. It will mix up with the aluminum. It will create a hot spot. So the daily cleaning, it should be inspected by the even sometime from the top management. The periodic repair and maintenance of the furnace should be happened properly. Keep the burner and blower in the good condition. See, melting and holding furnace. Thermocouple or a chamber controller for controlling metal temperature should be used. Avoid loose wiring. This also sometimes we see in the shop floor, loose wiring, lot of loose wiring. And don't give dross with molten metal over the holding furnace. Sometimes operator, what happens? They don't put the coverall or cover flags or any cleaning agent. They remove the oxide with some material. They keep the top of the holding furnace, and it will damage the furnace, and also loss of material and loss of furnace and loss to everyone. And cover up the furnace when not in use to prevent heat loss. Whenever the furnace is not in use, must be closed. So for that, when we give a manual cover, the operator is lazy to cover up the furnace. So we have to give some kind of mechanism, hinge type mechanism can be adapted. Initial charging with scrap is preferable. With ingot, it will create a lot of heat. It will take more time. So charging with runners is preferred. So now we will discuss about the process variables. There are 5 process variables that affect the quality of the casting. So metal analysis, metal temperature, die temperature, die lubricant characteristics, die filling conditions. In general, die casting is a setup dominant process. And the variable 2 and 3, continuous monitoring system is better to measure the variability of temperature related variables. 2 and 3, that is die temperature, metal temperature and die temperature. Variable 5 is a die filling condition, consists of the element of short profile that short monitoring equipment can monitor and measure. So short monitoring system can be used. And in the start of the first shot, the pouring without any turbulence. Less turbulence is very important in the short sleeve. So short sleeve optimization can be adapted. For example, the operator pour by the hand, always it will create the some turbulence. It will capture some air. So the operator have to take care, and operator have to be trained properly to pour the material without any turbulence. But it can be done by the auto ladle. The turbulence creates more oxides and entrap the air and gas. After the pouring, the dwell time, this is very important. The dwell time after the pouring of material into the short sleeve, sometime 0.5, 1 second, 1.5 second, or 2 seconds. It should be validated properly, part by part. A start of injection after completion of pouring for effective evacuation of air in the short sleeve. Combination of process parameters should be validated very carefully for best results. So the first phase plunger speed, I insist here sometime 0.08 to 0.5 mm. It should be validated properly for each and every component. So here we can see some kind of short sleeve optimization when you have a fully automatic machine. So short sleeve optimization, here you can see there is a, I will move a cursor here. See here the material is going and going hit at the moving die spreader and getting back and create a having a air. So here you can see the left side, there is a air entrapment in the short sleeve. This is the original short profile. And the right side you can see this is a modified. This modification can be done by using the auto ladle and your dwell time and the first phase speed. This can be optimized. This can be done in your software. When you have a software like Flow 3D or Magma, etc., then you can do that parameter. You can replicate. This is possible only in the automatic machine. for a bigger die casting machine, it will be very much useful. The second is plunger speed. So here I insist to use 50 to 60% of the total plunger speed. For example, when you have a manual machine, 5 meters per second, try to use 50% to get the automized velocity, automized flow of the material. Here, the automized flow means the material should get the same velocity from the gate up to the end of the fill. For this, you have to use 50 to 60% of the plunger velocity of the machine. If you use maybe more than 50, 60, what will happen? All the oil will drain in between. At the end of the fill, won't have any pressure to fill the material. So the aluminum mortar won't have any velocity at the top, at the end of the fill. So it will create the flow problem. And the specific casting pressure, here you can use 400 to 1000 sometime. So I insist not to go more than 800 kg per centimeter square. Otherwise, what will happen? The die will get more damage and the die life will get deteriorated. Then you won't get die life properly. The gate velocity 35 to 45 meter per second is nominal. It is sufficient. And sometime we will have 60 meter, but in some cases, very negligible amount of the filling problem. That's why we will have a 60 meter per second. Biscuit thickness 15, 20 or 25 or 30. So don't go below 15 plus 5 mm. Sometimes if you keep a plus or minus 5 also desirable. Try to maintain consistency in the process parameters. Here, consistency in the process parameter is very important, and the cycle time also very important to get the good output. PQ square, this is the one type of methodology to check whether the die is suitable for the machine. A PQ square analysis will yield the desired fill time and optimum gate area. The gate depth and location can be determined for the simulation. Here, this is the PQ square diagram. See, there is a diagram here. X-axis, you can see metal pressure and the delivery of the material at the x-axis, and the y-axis you can see the metal pressure. So from plotting this, a completed PQ square diagram is shown below. Notice that the goal is to predict where a given die will operate when mounted on a machine with known performance. Also shown is an operating window that is developed to match the needs of the casting quality requirements. The objective is to make a design that will have the die and the machine operate within the range of the developed operating window. Here you can see there is a gate velocity limit, bottom line and the upper line. Upper line is the maximum gate velocity line, and the minimum gate velocity line, and the slanting line is the machine operating line. So by using this methodology, you can find one window. If you draw a final line, the die line, you should cross the window line, the process window. Otherwise, what will happen? The die won't suitable for that machine. The PQ square, that is matching the tool with the machine. The machine should have a pumping capacity for the given tool. This is the idea. The plunger velocity, gate velocity, and the fill time for the designed plunger size should be available. So PQ square will help us to check whether the die is suitable for that machine. Otherwise, we have to check again the plunger size, the plunger speed, and the gate velocity and gate area, everything. This is one simple example I have put up here, the injection profile. So this profile can be tried in the auto ladle with auto spray and auto injection. For manual machine, it is not possible. Here you can see cursor. Can you see here?
Yes, sir.
Hello.
It's
Yeah.
visible, sir.
viewable, right? So here you see this is the constant speed curve. This is the second phase. Sorry. And the see here there is a cursor. This is a pressure dropping line. Here and this line is showing here is the constant acceleration. As I told you before, by using the injection profile and the short sleeve optimization, we can get this curve. This is a constant acceleration curve. So most of the air can be evacuated by adjusting the injection profile like this. Can I go next slide, or anybody want to see this?
Does anyone have any questions, or can you go to the next slide? I think you can go to the next slide, sir. They might be able to ask the questions at the end.
So this is the elaborated subject. This will take some half an hour to 1 hour. So you can go to next slide. The dye temperature. So here the dye temperature minimum 152, maximum 230 is sufficient. 220 degrees Celsius dependent on wall thickness of the casting. The dye lubrication, the ratio with water. Try to use mixing machine for consistency. See, in the some smaller die casting machines, operator always use some kind of cups or without any measuring equipment. It won't give you any proper ratio. So I insist here, try to use a machine like example. We can say dosatron like example, and plunger loop, and avoid excess lubrication. So when you use excess lubrication, we will lose money, and also the oil, the lubrication oil will go into the short sleeve and mix up with material. It will create porosity problems. So always try to use the plunger lubrication machine. It will give you a cost reduction and also quality improvement, or without any problems. Plunger tip and cooling. Right material with the proper cooling, it should be used. Dye loop spray or manual or auto. Try to use auto spray. Auto ladle settings. The settings should coordinate with the cycle time. Sometimes the auto ladle take the material and waiting at the short sleeve and loop for few seconds. It will lose the temperature and it create a problem. So what happens while the die is closing, the auto ladle should come to the short sleeve and should not wait more than maybe 3 to 5 seconds. In such a way, it should be adjusted. The hydraulic core settings, you have to use the last in and the first out. And the short sleeve cooling, some smaller machine, sometimes it's not necessary. For the medium size machines, more than for 350 degree, 350 ton, 420 or 500 ton. Definitely, if you use a short sleeve cooling, it will be a good result. And use integrated short sleeve. Till now, nearly most of the die casting companies are not using the integrated short sleeve. Try to use the integral short sleeve. You have a better plunger tip life, also the less rejections, and etc. The adapter auto extractor. If you want to reduce the manpower, if you put up an auto extractor for a 2 machine, you can use 1 operator. This also you can try. Now you discuss about the die and the die maintenance. Do preventive maintenance without fail as per the checklist. Everywhere there is a checklist, but we have to use properly. And the last off and first off, this is very, very important. When you have a last off from the shop, and the last off and the should be taken from the shop floor and given to the die maintenance to check properly, and it should be recorded properly, and the correction should be done properly. With the full shot, keep records. Die checklist must be used before loading in the machine. These are all the simple things, but what happens, it will give you a huge benefit. So, die checklist and periodic stress relieving should be performed. Coating like PVD It will delay the heat check or less spray also possible, and dye life also will improve. Dye polishing at the solder, no, not necessarily to polish the dye everywhere. As it will remove the film, hard film. It will help to get the easy release. So polish the dye at the solder points. Cleaning cooling channels by pumping hot water or diluted chemicals. We want to clean the dye inserts by using the normal water won't give the good result. Use the hot water with the pump. Try to avoid shimming. Shimming means sometimes you put the shim underneath the ejector pin or core pin or the inserts. Sometimes what will happen, the shim will jam and it will create a dimensional issue. So always try, don't put any shim inside the insert. Inspect the tool periodically. You should have a periodical inspection program, and replace the wear and tear parts, especially the pillar, bush, and the core pins. Sometimes the core pin breakage starts. Remove all the core pins and change. Otherwise, you will end up with many breakdowns and end up with many losses. So ejector pins also, if you have any damaged ejector pin, should be removed, changed. Proper preheating should be followed while welding the inserts. We want to go for welding the insert, proper preheating should be done. Maintain the tool history card and don't forget to record the maintenance and the improvement activities done in the tool for future reference. Sometimes, every time the people are doing maintenance, but they don't record properly. It should happen. During the production, proper die cooling, clamping, ejection rod, lock nut, hydraulic connection should to be provided. Everybody knows this, but why I'm insisting, whenever you have a single lock nut for the ejection rod, it will come out during the production. Then again, it will have a production interruption. So don't compromise these things and put 2 lock nuts. So this is one example. Without cooling, if you do not have a cooling, the cooling should be done. Otherwise, what will happen? So for this run, I want to run. So write some NCR like that. So what happened? It will create a problem. So don't allow these kind of small things. Adjust the spray properly at the appropriate point only. Use spray plan and get automated spray. So the spray tubes, when you have more spray tubes, when you have a smaller die, not necessary to open up all the spray tubes, only at the points wherever necessary. So for this, you should have a plan, a spray plan. Avoid spray to cool the die instead of use the cooling channels. Many of the auto die spray area, people are using the spray to cool the die. This practice need to be avoided. And trial history card. So here, maintain the trial history card from FOT till the SOP. So when the start of FOT, everything should be recorded in the trial history card. The trial history card should be separate from the normal history card. Record the trial settings and observation for the analysis and the future improvements. This will help give you very good information during the repeat tool and during your FMEA for the next tooling. Now we will discuss about the machine. The preventive maintenance of the machine should be happened. So the daily maintenance, we call as a clean the machine, lubricate and inspect, tighten. Weekly maintenance, maintain a heat exchanger, auto spray head, auto ladle, plunger lubricant system, extractor at the good condition. So this should happen during the weekends. Give little effort. Make a few people to assign this assignment during the weekend. You will not have any problem during the production. Replace the worn-out parts like bushers, toggle pins, oil seals without fail. Arrest any leakages. Any leakages in the machine, oil leakages or water leakages should be arrested. So inspect and charge into as per manual. Sometimes it should be as per the manual, not approximate and as per the experience. Should be as per the manual. Maintain the parallelism. Use perfect block, not the tool. Sometimes in the automatic die casting machine, the people take the good die, they put into in between the two platen, they check the strain. It is not good practice. Must use the parallel blocks. Strain gauging tie bar and keep record. The strain gauging should happen in the periodic, maybe 3 months once or 6 months once. Otherwise, what will happen? We will have a tie bar strain, tie bar breakage, and also die flashing and problem, etc. Maintain the machine lubrication system properly. This is also one of the very, very important area, and people don't focus on this. And greasing point. Keep injection system properly. The coupling. If the coupling have 8 screws, must use 8 screws. Sometimes if one screw broken, must be replaced immediately. And the seals also changed properly. And don't bypass any maintenance and safety interlocks. Don't remove any sensors like tie bar strain. For example, when you want to run the 1400 ton die into the 1250 ton machine, sometimes they remove the strain gauge and bypass the information to the machine to run the production. This should be avoided. What will happen at timing? It will give you a result. We can think, but what happened? We are damaging the machine. So this should be avoided. Use a high temperature wire and grease in the ladle unit. Sometimes we have a problem in the auto ladle. We have take a normal wire, it won't give you result, and it will damage after 1 hour, 2 hours. So always use the high temperature wire and the good grease or good material for the auto ladle. In auto ladle, properly apply coating over the probe and keep clean the probe, especially at the tip of the probe. What happened? Operator, they need to be trained properly. Otherwise, they apply the ladle coat at the tip of the probe, and it don't sense properly. The auto ladle will dip into the material. This is a very, very dangerous problem happening in the die casting. So the tip should be kept clean. They should be educated properly. Don't hit the probe and sensor ladle unit by tongs. This is the sometimes the operator take the tongs and hit the sensor. So to remove the material sticking at the sensor, it will damage sometime. Maintain the cooling tower and water quality, water pressure. Avoid leakages and spillages in order to maintain the hydraulic oil temperature as per the requirement. The hydraulic oil temperature is very important for the machine to perform well and give the good quality casting and good output. So this should be maintained. This area are neglected by the people. That's why I'm insisting. And the production management. So always should have a plan and do check act practices. And production and resource plan should be kept properly and followed properly. And the preparation for uninterrupted output. Preparation always should be there. Proper allocation of resources. Resources should be properly allocated. SOPs with the proper validation for all operations with proper training to workmen. Any process, it may be the die casting process, it may be a trimming process or vibro process or shot blasting process. It should be validated properly and recorded properly, and SOP should be created and should be hanged nearby the process place and should be trained with the people. The daily meeting should happen. One meeting in the shop floor to discuss about all issues is sufficient, not necessarily for the production meeting, quality meeting, delivery meeting. One meeting is sufficient. Maintain consistency in the cycle time and the process. Setting a condition and maintain it throughout the production cycle without deviation. So here setting a condition means when you load the die, the condition should be followed for each and every loading. It will give you a good output and quality. Quality requirements should be displayed, conveyed, and trained the workman with the samples, inspection plan, and inspection method. So the quality requiremement should be conveyed up to the bottom line, even to the helpers level. Train the shop floor inspector and supervisor to take decision as per guideline to speed up the work. Sometimes the operator need not to wait until the senior level people come and give the direction. So it will create some time loss. So use certain level of decision making capability. Changes are coming in. So now we will discuss. Maybe we are coming to almost end of the session. We will discuss shortly about the customer demand. Changes are coming in new product developments for performance improvement and further weight reduction by reducing the wall thickness to achieve emission norms in the automobile components. New quality requirements and changes in the porosity level, zero porosity or lesser size, tighter tolerances are expected. Cost reduction is also expected for financial benefit from the customer. These are all the customer demands nowadays from the automotive industries or etc. Adapting to new environment and quality demand is required. Now we have to adapt to the new environment and new quality demand. Adapting to new technologies and methods are needed, like vacuum die casting, thermal imaging camera. We can use to check the die temperature or process improvements, real-time process monitoring and control, die life improvements, asking for more die life by customer to meet out our new challenges. Here, many new technologies are coming in. We have to adapt to get the benefit both by the customer and the supplier. So be ready for new challenges to achieve new requirements, cost and quality. So training necessity of the employees. Now we should have a plan to improve and upgrade the knowledge and the skill level of employees by providing training to meet out these challenges along with adapting new technologies. Nowadays, operators are very young and they should be trained properly to get the good output and delivery and cost. So our plan from die-casting engineering solution, we can provide more webinars and training sessions to improve the knowledge and skill levels and many more important topics upon request. On-site training also possible. On-site training session can be provided upon request. Please contact us for any consultancy and training requirements. Here, I insist all the way from the beginning until the end, the very smaller things are neglected by the people. Thank you. This is our contact address. If anyone want to take it. You have any, hello?
Yes, sir. We are here. So,
any questions?
Anybody having questions, please feel to ask. Raman sir, shall we close the...
Yeah, if any questions is raised, okay, after this presentation, you can send the mail to, he has provided the mail to, so that the question can be sent to his mail and further clarification can be obtained. So,
yeah,
you can conclude.
Okay. All right. First, thank you everyone for attending our weekly webinar. And thank you, Mr. Swaminathan. The presentation was really explanatory and right from the basics of pressure die casting to in detail was explained. So we thank you for the effort taken. And I'm sure many of them would be having a lot of questions and probably just shy to come up with their questions. You might be getting them separately in your email or message.
No problem. No problem. So, even my WhatsApp number also can be used.
Exactly, sir. So you have given us all your information. So thank you for your time. Thank you for your effort. And IIF is always happy to have you, sir.
Yeah, thank you very much for the opportunity given. If possible, I can also give in coming days. We can go for the next another sessions.
Sir, I think we have a question from Santosh. He said about the biscuit thickness. I have a doubt on that. How do we determine the thickness based on machine capacity or casting thickness?
See, actually, this is not based on the machine. It's based on the die. For thinner components, without any pressure, intensification pressure, you can use 15 to 20 mm is sufficient. And if you need a more pressure of intensification, the biscuit thickness, you have to use 20 to 25 mm, because it will give you it will transmit the intensification pressure through the runner to the cavity. For that, you need to have a thicker biscuits, not necessary to go more than 30 or 35 mm. Otherwise, what will happen? You will loss of material, and also the plunger will have a more pressure to push out the plunger biscuit from the fixed die. So this all based on your casting requirement and the die design.
Thank you, sir. And Santosh, I hope your question was answered. Anybody else have any other questions? Thank you for your time. Thank you everyone for attending, and hope you guys have a good weekend. Okay.
Okay. Yeah. Thank you.